That cabinet door above your stove, the one you wipe with a wet rag every couple weeks and it still feels sticky when you touch it, that's not dirt. Dirt comes off. What's on that door is grease that's been cooking itself onto the wood for years, one dinner at a time, and by now it's basically turned into a varnish. I've seen kitchens where the homeowner swore they cleaned every week and the cabinet finish underneath the grease was a completely different color than what they thought their cabinets looked like. Not dirty, different color. I want to show you something I've used on commercial kitchen hoods, restaurant backsplashes, and my own house, and it costs about $2 a box and lasts most people a year. It's not a spray you've seen on TV. It's not vinegar, and vinegar is actually one of the worst things you can use for this. I'll get to why. It's a plain white powder that's been sitting in the laundry aisle of every grocery store in the country for decades, completely ignored, while people spend $15 a bottle on degreaser sprays that barely touch the problem. My grandfather used this stuff to strip wax off gymnasium floors before he ever used it in a kitchen. When I started doing residential jobs and ran into the same baked-on grease problem over and over, I remembered watching him mix it in a bucket and figured if it can lift floor wax, it can lift chicken grease. It worked the first time I tried it on a cabinet I genuinely thought was going to need to be repainted. So here's what we're doing. I'm going to show you exactly what this grease actually is at a chemical level, because that matters. It's the reason soap alone never works. Then I'm going to walk through the 3 mistakes almost everybody makes trying to fix this, including one that can actually damage your cabinets permanently. And then I'll give you the full method, step by step, the same one I use on jobs, including the part most people skip that makes the whole thing actually work instead of just smearing grease around. If you've got a kitchen that's been lived in for more than a couple years, you've got this problem somewhere, whether you've noticed it yet or not. 2. The problem. Walk into almost any kitchen that's been used regularly for 3, 4, 5 years and run your hand along the top edge of the cabinets right above the stove, not the front, the top edge where dust would normally sit. If it feels tacky, almost like it's got a very thin layer of tape residue on it, that's grease. Now check the wall behind the stove, especially if there's no backsplash tile, just painted drywall or wallpaper. You'll usually find a faint halo pattern radiating out from where the burners are. That's not staining from smoke. That's airborne grease that landed and stayed. The reason nobody catches this early is that it doesn't look like a mess. A grease fire or a boil over you clean immediately because it's obvious. But this kind of buildup happens in layers so thin you can't see any single one of them. Every time you fry something, saute onions, sear a steak, cook bacon, the oil doesn't just stay in the pan. A percentage of it turns into a fine mist that floats up and settles on every horizontal and near horizontal surface in a 6 to 10 foot radius. Cabinet tops, range hood filters, the underside of upper cabinets, light fixtures, even the ceiling if you cook a lot of high-heat meals. One layer you'd never notice. It's invisible. But most people cook multiple times a week for years in the same kitchen, and each session adds another microscopic film on top of the last one. By the time it's visible, by the time it's yellowing the paint or making the wood look dingy instead of its actual color, you're not looking at one mess. You're looking at hundreds of layers stacked on top of each other, each one a little more cooked on than the last. I worked a house once where the owners had lived there 12 years and never had the range hood professionally cleaned. When we pulled the filter housing apart, there was a layer of solidified grease over a 1/4 inch thick, and it had the consistency of hardened candle wax. That's 12 years of Tuesday night dinners, one invisible layer at a time. That's the part people miss. This isn't a cleaning problem you solve with more scrubbing, it's a buildup problem, and buildup problems need a completely different approach than surface dirt. 3. Why it happens. Here's the part that actually matters, because it explains why dish soap stops working after a certain point, and it's not complicated once you see it. Fresh cooking grease is just oil. Oil and water don't mix, which is exactly why dish soap works so well on a greasy pan right after dinner. Soap molecules have one end that grabs onto oil and one end that grabs onto water, so it lifts the oil off the surface and lets water carry it away. That's basic emulsification, and it works great on grease that's still, chemically speaking, just sitting there as oil. The problem is that grease doesn't stay as oil once it's exposed to heat and air for weeks or months. It oxidizes. The fat molecules react with oxygen in the air and start linking together into longer, more rigid chains. This is the exact same chemical process that turns linseed oil into a hard, dry finish on wood furniture, or an old bottle of cooking oil in your pantry gummy and thick instead of pourable. Heat speeds this reaction dramatically, which is exactly the environment right above your stove. So the grease that lands there isn't staying as oil. It's slowly curing into something closer to a plastic or a varnish. Once that happens, dish soap can't do its job anymore, because soap is built to grab loose oil molecules and pull them into water. It's not built to dissolve a solid cross-linked polymer. You can scrub with dish soap on cured grease for 20 minutes and get almost nowhere because you're trying to emulsify something that's chemically stopped behaving like a liquid. This is exactly why alkaline cleaners work where soap fails. A strong alkaline solution doesn't emulsify grease. It breaks it apart at the molecular level through a reaction called saponification, the same reaction that turns fat and lye into soap in the first place. It attacks the ester bonds holding those fat molecules together and breaks the whole structure down into something water-soluble again. That's a fundamentally different mechanism than what dish soap does, and it's the reason a $2 box of washing soda can outperform a $15 spray bottle that's built around soap chemistry. I didn't learn this from a chemistry textbook. I learned it from watching the same method fail on year-old grease and succeed on month-old grease, job after job, until the pattern was obvious enough that I went and figured out why. But even once you know this, there's a wrong way and a right way to use an alkaline cleaner on your cabinets, and getting it wrong is how people strip finish off wood that took them years to build up. Number 4. Common mistakes. Mistake 1. Reaching for acid-based cleaners, especially vinegar. Vinegar gets recommended for everything online, and on fresh grease or hard water spots, it does fine. But vinegar is acidic, and acids don't break down grease. They're actually the opposite of what you need chemically. Acid is great for dissolving mineral deposits, limescale, soap scum, rust. It does almost nothing to fat molecules. What I see happen constantly is someone sprays vinegar on baked-on cabinet grease, wipes it, and the rag comes away looking dirty, so they assume it's working. What's actually happening is they're just smearing the surface layer around and picking up loose dust, while the actual cured grease underneath doesn't move at all. A week later, it looks exactly the same, sometimes worse, because now there's a hazy vinegar residue mixed into the grease film. Mistake 2. Scrubbing harder instead of changing the chemistry. This is the most common one I see, and it's understandable. When something's not coming off, the instinct is to press harder or grab a more abrasive pad. On cured grease, this almost always backfires. Grease that's polymerized is soft enough to smear, but tough enough to resist most scrubbing. So what actually happens is you're dragging a thin layer of grease across the surface and pushing it into the wood grain, into cabinet hinges, into any texture or seam on the surface. I've pulled apart cabinet hardware on jobs where the previous cleaning attempt had packed grease into every screw thread and gap because someone scrubbed instead of dissolving. And if you go up to a green scouring pad or steel wool on a painted or finished cabinet, you're not just failing to remove the grease, you're creating thousands of microscopic scratches in the finish. Grease loves those scratches. It gets down into them, and next time it's twice as hard to remove, because now it's not sitting on a smooth surface, it's embedded in a scratched one. Mistake 3. Relying on heat and water alone. Some people figure hot water should melt the grease enough to wipe it away, so they'll run a rag under scalding water and go at it with nothing else. Heat does soften cured grease somewhat, that part's true, and it's actually useful as a first step, which I'll show you. But heat alone doesn't break the chemical structure of oxidized grease. It just makes it slightly more workable temporarily. The second it cools back down, it re-hardens right back onto the surface, sometimes in a slightly different spot than where it started. I've watched people do this for 45 minutes on a single cabinet door, wiping and re-wiping the same softened grease around, wondering why it never actually leaves. Water without the right chemistry behind it is just spreading the problem, not solving it. The pattern in all three mistakes is the same. None of them actually change what the grease is made of. You need something that breaks the bond, not something that just moves the grease from one spot to another or makes it temporarily softer. That's the whole reason the method I use works. It's built around changing the chemistry, not fighting the grease with force. Here's exactly how I do this. In the order I'd do it, with the same materials I'd bring to a real job. What you need: washing soda, sold as sodium carbonate, usually near the laundry detergent, not to be confused with baking soda. A box costs around $2, and one box will last you well past a year of kitchen use. You'll also want a bucket, hot water, as hot as your tap will give you, 2 microfiber cloths, a soft bristle scrub brush, the kind sold for grout works fine, and a pair of rubber gloves because washing soda is alkaline enough to dry out your skin with repeated contact. Stage 1. Dry clear the surface first. Before any liquid touches the cabinet, wipe the surface dry with a microfiber cloth to remove loose dust, crumbs, and any grease that's still soft enough to lift without effort. This sounds like a throwaway step, but skipping it means you're about to mix loose dust into your solution and drag it around as a paste, which makes more work than less. 30 seconds every surface before you introduce any liquid. Stage 2. Mix your solution. In your bucket, dissolve about a quarter cup of washing soda into 1 gallon of hot water. Stir until it's fully dissolved. You shouldn't see any granules sitting on the bottom. The water should be as hot as you can comfortably work with because heat speeds up the saponification reaction significantly. This is where the heat helps idea from the common mistakes section actually pays off. Heat isn't doing the job by itself, but it makes the washing soda work faster and more completely. But there's one step people always skip right here, and it's the one that actually determines whether this works well or just okay. Don't apply this solution cold to a cold cabinet surface. Warm the surface first. I'll take a microfiber cloth, soak it in the hot solution, wring it out so it's damp but not dripping, and lay it flat against the greasy area for about 60 seconds before I do any wiping at all. That short dwell time lets the heat and the alkaline solution start breaking down the surface layer of grease before you ever put pressure on it. Skip this and you're scrubbing against grease that hasn't started dissolving yet, which means more effort and worse results for the exact same solution. Stage 3. Work top to bottom. Once the surface has had its 60-second warm soak, wipe with the grain of the wood using the damp cloth, medium pressure. You're not scrubbing yet, you're wiping and reapplying solution as needed. Always work from the top of the cabinet run down to the bottom. Grease and grime will run downward as it loosens, and if you clean bottom to top, you're just re-dirtying sections you already finished. For areas where the grease is thicker, usually right above the stove or on cabinet doors closest to the range, this is where the soft bristle brush comes in. Dip it in the solution and work it into the surface in small circular motions, focused pressure but not aggressive. You should see the cloth picking up a yellowish-brown residue as you wipe it away. That's the grease actually lifting, not just moving. If the cloth is coming away clean and the surface still looks dingy, that's your sign the grease hasn't broken down yet. Go back to stage 2 and let it sit longer before wiping. Stage 4. Rinse. This step gets skipped constantly and it shouldn't be. Washing soda is alkaline, and if you let a film of it dry on painted or finished wood without rinsing, over months of repeated cleanings, it can dull the finish or leave a slightly chalky residue, especially on darker cabinet colors where any haze is more visible. After you've lifted the grease, go back over the entire surface with a clean cloth dampened in plain hot water, no washing soda this time, to rinse away any leftover solution. Then dry immediately with a separate dry microfiber cloth. Don't let it air dry, especially on wood, because water sitting on a finish for extended periods is its own separate problem. Pro tip, and this is the one that actually separates a good result from a great one: after you rinse and dry, go back over the whole surface one more time with a completely dry microfiber cloth, buffing in small circles, like you're polishing rather than cleaning. This does two things. It picks up any last trace of loosened grease or residue that a wet cloth alone tends to leave streaked across the surface, and on most cabinet finishes, it actually restores a bit of sheen that's been buried under grease for years. People are consistently surprised that their cabinets look almost glossy again, not because I did anything special in that step, but because they're seeing the actual finish for the first time in a long time, without a layer of oxidized grease dulling it. For range hood filters specifically, since that's usually the worst spot in the kitchen, skip the cloth and wipe method entirely and instead submerge the filter directly in a bucket or sink of the hot washing soda solution, fully underwater for at least 20 minutes, longer if it's been years since it's been cleaned. Metal filters can handle a longer soak than painted wood can. After the soak, most of the grease will wipe off with almost no scrubbing at all because full submersion lets the solution attack the grease from every angle instead of just the surface you're wiping. One more thing worth mentioning because I get asked constantly. This method is something you don't want to use on unfinished or unsealed wood or on any surface where you're not sure what the finish is. Washing soda is safe on painted, sealed, laminate, and most finished cabinet surfaces, but on bare or oil-finished wood, it can lift color and dry the wood out. If you've got open cabinetry or butcher block near your stove, test in a hidden spot first, or use a milder approach specifically made for unfinished wood. Do this every 4 to 6 months on the areas closest to your stove instead of waiting until the grease has had years to cook itself into a hard layer, and you'll never be standing in front of a cabinet wondering if it needs to be repainted. Catching it early is genuinely the difference between a 15-minute wipe down and the hour-long job I described earlier in this video. That's the whole method. Same one I've used on hoods, cabinets, and backsplashes that looked like they were beyond saving. $2 of washing soda, a little heat, and knowing to let it sit before you wipe instead of scrubbing right away. If you've got a kitchen surface you've basically given up on, something you've decided is just going to look like that now, put it in the comments. I read through them, and if I see the same problem coming up over and over, that tells me what to cover next. If this is your first time here, subscribe. I put a new video up covering a different real cleaning problem every week. No filler, just what actually works based on jobs I've done. And if grease buildup is a problem in your kitchen, there's a good chance your range hood filter is worse than your cabinets. I've got a full video on cleaning those properly. Worth watching next if you haven't already tackled that one. I'll see you in the next one.